Hello! In this short video I will demonstrate how Smart Electrical can be used to summarize loading on electrical distribution buses. In this example, I have created an overall single-line diagram that represents a simplified version of the electrical distribution system. For this scenario, we are assuming the facility operates in two cases, normal and backup. In normal operating case, the first generator supplies power to the facility, while the second generator starts up to provide power in the backup case. In this example, there are three operating loads. During normal operation, the two electrical loads connected to bus A run continuously, while the load on bus B remains on standby. When the facility switches to backup case, the two motors under bus A will operate intermittently, one at a time, while the other load under bus B will run continuously. The loading requirements for each operating case are defined using the operating case properties window. Here you can specify the load's mechanical power, operating mode, and the corresponding coincidence factor for each case. The goal of my task is to summarize the total power consumption of the entire facility for each operating case. First, open the Preferences window and make sure that the load summary is set to use individual load coincidence factor, include coupled buses connected by coupler and riser, and account for converting equipment power losses. Now switch the model's operating case to normal. This assumes the facility is being powered by the first generator with power distributed to the loads through the downstream buses. The system will account for the power consumed by the electrical loads assigned to operate in the normal case and including the transformer power losses. To ensure power does not flow from the second generator, set the connection mode property of the feeder circuits to disconnected. To better visualize the connection mode of the circuits in the drawing, we can use the display set functionality. I have configured it to highlight connected circuits in blue and show disconnected circuits in red. Next, run the Calculate Bus Loads for all planned buses command. Once the calculation is complete, you can review the loading summaries on each bus. For the next step, switch the model operating case to backup. This requires closing all drawings, switching the operating case, and then reopening the drawings. In this case, the facility is assumed to be powered by the second generator, with power distributed to the loads through the downstream buses. The system will account for the power consumed by the electrical loads assigned to operate in the backup case. To ensure power flows from the backup source, I set the circuit connection mode back to connected, while the circuits supporting the normal operating case are set to disconnected. Apply the display set again to refresh highlighted circuit modes on the drawing. Run the command to calculate bus loads for all planned buses. Once the calculation is complete, review the loading summaries on each bus to see the power consumed by the electrical loads assigned to operate in the backup case. In the same way, you can summarize bus loadings for electrical data models of any complexity, including redundant and meshed systems, as well as radial and ring-type infrastructures. I hope you enjoyed this video. Thanks for watching and have a wonderful day.